Okay, everyone. Guess we're ready to start now. We got the everything worked out. This is my presentation called Exploiting SCADA Systems. And just brief background. Well, my name is Jeremy Brown, and I'm a vulnerability research engineer at Tenable. And I like to play with SCADA software, so the presentation is focused on vulnerabilities in SCADA software. So let's get started. So a lot of SCADA software runs on AIX, OS2, Linux, but most of the modern software runs on Windows. So the framework that I'll be demoing later will show exploiting the SCADA software on Windows. So SCADA software used on workstations, you can use it on remote. There are even mobile apps to control remote aspects of SCADA, and that's what the iPhone app shows. So attack vectors via software vulnerabilities. With SCADA software, they're used the same. They're in the same programming language as a lot of the other applications, C, C++. So they share the same vulnerabilities as any other application. So whether that be client-side attacks from the web browsers, click on a malicious link, anything like that, whether it's not patched, email, or even malicious servers attacking clients, SCADA clients, and things like that. Also server-side attacks from the internet. If the SCADA software is connected to the internet, it's vulnerable as just anything else, or the internal network if it's firewalled or not accessible by the internet. So I'm just going to skip through just some of the brief introduction. Clickjacking, I thought that would be funny. You never know, maybe it's vulnerable to clickjacking. You never know. So what's wrong? What's the problem with SCADA software? Well, security has been implemented as an add-on instead of being built around the product from the ground up, especially for a lot of the older versions of software. In SCADA plants and things, the security is kind of a hindrance. So it wasn't really built. Everything back then was kind of built just to be easy for the operators. So security wasn't really a priority until people figured out people were hacking into SCADA systems. And then systems typically are installed for long term, and software upgrades may require new hardware. So when SCADA systems are installed, they are put there for maybe a decade, 5 years, a decade, 2 decades, something like that, for a long term. So when they put everything together, they're not looking to make upgrades for a long time. So if vulnerabilities come out, or patches, or new versions, they may require new hardware just to upgrade. And then just kind of thing that I noticed that may be typical for a lot of SCADA systems, when they go into an audit or something like that, a lot of administrators are saying, this isn't connected to the internet, or they can't access this from this network because it's separated, or on a different network, on a different subnet, something like that. But still, something somewhere is connected to something that may be connected to the internet. The whole process of communication means you can communicate with things anywhere. You got to be able to communicate it with, to control it. So unless it's strictly physical access, something's got to be connected to something, and a lot of times it's also connected to a system that's connected to the internet. So if an attacker gets control of a system that has access to the internet, he got access through the internet and got access to the internal network. So even though the system wasn't connected to the internet, it is now vulnerable to attack from the attacker. So. And then vendors can take their time with updates, and managers can take their time updating. Since they're going to be in place for a long term, a lot of the patches and a lot of the upgrades may not occur for a long time. So even if you find bugs in SCADA software it could be 5, 10 years old, or even the latest software, you still have a chance to attack something on the network, because chances are they haven't upgraded for so long that it's still going to be vulnerable. So. And through my research, I found that there are a ton of vulnerabilities in SCADA software. It's just, I don't know if they're not, I guess a lot of the old programming practices have to do with this too. And it's just, they're not, the code is not secure. Plainly saying, it's not. They should really do some in-house testing, because you could simply, I mean, some of the vulnerabilities I've found, I've opened up a hex editor of the file format that happened to be used in the SCADA software, looked at an interesting place, and put a bunch of characters, a long string in there, closed it, saved it, closed it, ran it in the software, crashed. It's just, it's not stable in the security aspect. So just kind of, who may find the bugs? I mean, you never know who may be looking, but you never know who may come across them by accident or anything else like any other software. So it could be employees, and I just had a couple pictures here. That guy looks kind of curious what he's doing. Hackers, the ones up to no good, which according to how you look at it, black hat, white hat, gray hat, whatever. But it's kind of the typical evil-looking, cartoonish, evil hacker. I don't know. Kind of looks kind of cool to me, but I don't know. Security researchers, security professionals, according to how you interpret it. We know everyone here has at least 6 or 7 monitors in their workstation, so this guy's a clean representation of all of us here. And then, really, I found out you don't even have to have a lot of experience with dealing with security vulnerabilities. You can come over, you can find them by accident. A lot of people do, but anyone that cares to look could find vulnerabilities in SCADA software. It's insane. So, I guess I kind of moved a little quick here, but dealt this to kind of the middle of my presentation. I want to introduce exploitware. Exploitware is, well, I started out, I was finding all these vulnerabilities in SCADA software, and I was like, well, what am I going to do here? I kind of, I thought about writing Metasploit modules for them, to deal with the exploitation part, which is great. You can interchange payloads, you can, host, you guys are familiar with Metasploit, you know what it can do. But I was like, well, kind of bored, so maybe I want to start a project here. And never really wrote a framework before, not in this sense, not a penetration testing framework. So I was like, well, I had some code I could reuse and start on a new project. And I was like, well, I want to learn some stuff too. So I just basically in my spare time created exploitware. And exploitware is just a framework designed to specifically penetration test SCADA systems, more specifically the software side of SCADA systems. And I've used it I haven't used it, of course, in any protection systems. I just used it in my lab with my test systems. But I found you can get reliable exploitation just by, even reusing payloads and things like that. It was pretty easy to design the framework, and I just kind of put some things, I guess, similar to concept of Metasploit or Canvas, but it's focused on SCADA software. And I wouldn't dare say it's anything close to Metasploit or Canvas, but that was my original idea when I wrote it, something that I could use to check SCADA systems for vulnerabilities. So it was pretty nice to do. It can check the systems for the potentially vulnerable software. I've written some local checks. It can test remotely, if there's any version strings that come up, or it can detect the headers in the requests. Exploitation is optional but readily available. Like I said, the point of the framework is not just exploitation. That's what kind of the Metasploit was. Metasploit can check with them too, but it's kind of just, if you go into a pen test and say, hey, we got some SCADA systems running here, we've got some software running as well on them, of course. What can we find out that's vulnerable, and what can we see, what can we exploit too? So it has checks. It's also kind of added in an auto pwn feature, which I thought is pretty necessary for any exploitation framework. It's pretty cool to do. You can just hit the -A and it'll go through and check for all the vulnerabilities it has in the database, and if it finds any, it'll exploit them. But the payload, it just has one payload right now, which I haven't really done much development on it recently, but it just adds like a user, like exploit, password, where, something like that. You can use anything. You might have to adjust the exploit for some of them, but anyways. But like I said, the point of it's not just for exploitation. The point of it is to, it has local checks, remote checks. It can, just a brief way you can check the SCADA environment for anything that may be vulnerable. But the exploits are 0-day, and I haven't worked with any of the vendors yet, but I plan to in the future. But for this, they're just kind of let you know, kind of the post-audit. The pre-audit would be, before they shipped it out. I kind of do like the post-audit, like the vulnerability research with them and see, what exactly is vulnerable. And everybody loves 0-day. And the methods I use for identifying the vulnerabilities. I went from manual testing, like I said, some of them actually, when I first started looking at them, I just wanted to look at the file format briefly, through a hex editor or something, before I dug into it deeper. So I just opened a hex editor and I was like, well, I wonder what happened if I, curiosity gets the best of you. What if I happen to enter a long string here, or changed, this value to an FF, or, just simple auditing. And I found that after I saved it and ran it with the program, it would crash. I was like, wow. And then, you do crash analysis after that. And some of them are actually vulnerabilities. Some of them, like buffer overflows, like easy, direct EIP override, easy. Some of them were memory corruption. Some of them were kind of harder to exploit. Different kinds of memory corruption, maybe pointer corruption or something like that. But it was really easy with the manual. That was manual testing. And fuzzing, of course, and any file format fuzzer can set it up to run the application, log the crashes, things like that. So I didn't actually use much fuzzing for the exploits in exploitware. It was just too easy. Like I didn't even need to. Like I found a number of vulnerabilities just by manual testing, just playing with it. That's how easy it was to exploit. And then some was reverse engineering. I don't know if you guys seen, SCADA kind of dropped my 0-day a few months ago. I was reverse engineering the EDS file format. And I just kind of went through a brief example. It actually gave me the error messages. I didn't even have to reverse it. It would actually give me the error messages to properly format the file. And then I went into, after I seen that, I was like, I don't think it's giving me everything, so I wanted to reverse it and see what other options were available. So I went through and done that, and I found a bunch of, same buffer was vulnerable, to a bunch of, it was, I think, a Unicode buffer overflow. So I just went through, found it, and then I didn't really post any details yet because I hadn't contacted the vendor or anything. And I just kind of wanted to do an example of, kind of black box testing and then going into reverse engineering. And then somebody, apparently, I guess it was my fault too, they knew what the EDS file format was, they knew what programs used it in SCADA. So they, SCADA, I guess somebody contacted SCADA and told them about it, and they dropped my 0-day and stuff, but it happens. Excuse me. Okay, so that was the methods. It was really, I didn't use that much reverse engineering just because it wasn't necessary. I like to reverse engineer just to do research sometimes, but most of the vulnerabilities came from manual testing, like manually changing variables in the web parameters, or changing file formats, or just connecting to the server and sending a long string. Like the exploit I'll be demoing today, actually the vulnerability is I guess on receive. It just receives, it doesn't even format the buffer. The vulnerability is in receiving all the data into the input buffer. So I didn't need anything. I basically just connected to the server and sent the long string and crashed. And then I ran it in, WinDB or, Immunity, I can't remember what debugger I was using then, but install, I was overriding some other variables too, and I kind of backed off on my payload a little bit, and then I found out I could get, EIP override. It's easy. So all these bugs were really not challenging at all to find. Some of them, like the integer bugs, were kind of, I don't know, they were harder to analyze and find, I guess, because you can just, manually send -1, negative whatever, or a large value, 65536 or whatever, 65535, whatever, and find them. But it's just really easy. And the research and development findings I found, I probably went through the process over, I don't know, 3 or 4 months, just on and off, looking at different SCADA software and finding vulnerabilities. And the findings range from, some of them were remote code execution, or I guess if you look at it in file formats, it'll be local. But if you share the file or something, it turns into remote. Or if you can access it through a web browser, it turns into be remote anyways. And then to denial of service, there was tons of denial of service bugs. Wasn't really that big a deal. Well, I guess it is in SCADA software, but as a security researcher, you really don't look at denial of service of being high profile, unless it's something that takes down like the entire network. But in a SCADA environment, if you crash the server, that's sort of a big deal. And then integrity lost. There was everybody thinks ActiveX bugs were dead. I even found some ActiveX vulnerabilities led to integrity loss, like overwriting files or changing files, deleting files, something like that. So they were interesting, the findings were, but most of them, half or at least most were the vulnerabilities led to remote code execution. So it's pretty interesting. And so I've talked through to the demo, and I've kind of use a lesser version of exploitware. I only included there was a slew of vulnerabilities, but I only included one and kind of removed some information, so because I didn't want anybody to know. So, but I'll demo that now in a virtual machine. If I can, hopefully I won't mess up the screen like we had earlier. Let's see. And the application or the presentation won't crash. I had that happening earlier, but so far so good. Okay, you guys can see that. Full screen mode. Everybody remember right control, just in case I forget. Okay, so this is just a Windows XP Service Pack 3 box. And just, I think this is pretty much default configuration. And I know that it may be different in other environments, but this is just the default. And it's got all patches, all updates and everything current to maybe a week ago when I made this virtual machine. So the exploitware folder, I've kind of dumbed it down a little bit, but basically in the folder, let's see, I'll open up the folder and show you guys real quick. All right, so it's just the exploitware program and just the compiled, binary, and then you got the pack folder, which contains all the exploits in case you want to exploit. So, and there's only one in there. You guys are probably not interested in that anyways, but I'll show you exploitware. It's got the cool little header on it, and then you got -target for the target, and I'm sure you guys can read, but you can get information about the exploit, run the check, you can run a certain check, and I call them SPIDs, just exploitware IDs, which had a different name before I named it exploitware, but still. Excuse me? I don't know how to do that, I'm sorry. What is it? Okay, properties? I'm sorry, my Windows skills are not font? Yeah, makes sense. Okay. I'm getting a lesson here myself. Is that going to be appropriate? So glad to have you guys here. You guys are awesome. Okay. You see that good? Thank you. You guys really want me to change the green on black? At least my presentation is going to go maybe the time slot, so that's cool. We can do this. Yellow. I click yellow, right? That's not going to be good. I'm going to go with green. Are you serious? I like the green because it looks cool, but you guys? All right. Yellow, I guess yellow's better on the reading, so. Well, that's, okay, so exploitware. So I'll just do a couple functions of it. Like, I only included one exploit. There's many more than that, but I didn't want anybody to steal my O day, so let's do this. Information 1. So it's all kept in a database, and hopefully I NA'd all the stuff I didn't want anybody to know. Yeah, I think so. But I just put it in a flat file database right now, and it just prints out status, 0 day, vendor names. That's not the real vendor name and product title, but I changed that. And then you got vulnerability description, just like a brief thing with it, and the revision. If I added something onto it, 0.1, all that. Made it universal. I think I used a DLL out of the binary that it was included. So easy stuff, but and it's pretty much 100%. I guess I can say 100% reliable. If something messes up. So, and then let's see. I guess I could shit. Excuse me. I forgot how to use the up button, so. And then you can just run the check and exploit it. But I've already got the vulnerable daemon running, daemon, something. And so we're just going to show the auto pwn feature, which is awesome to me. Like I think every exploitation thing or penetration should have auto pwn, just for like people seem to love that. I don't know. It's odd. It's cool. But yeah, you don't really, okay, I'll do the check first because I said it's not really for exploitation, but I mean it is, but it's optional, so I'll do the check first. Shit, I cannot type. Check. So you can check for a specific one, but I'm just going to check for the first one. So it just goes through, it just runs a simple Windows, checks the registry for it or whatever. Says exploitware demo is installed, checking it. If it's a remote service, it can check the it's running on the local host, see if it's accepting connections. I haven't done anything really cool with that, like version checking that much either, but this one really doesn't. This is the one where I just sent like the long character string, and it, I owned it, so it doesn't really have that many information stuff anyways. So my server is listening, so that's the check you can go through. And then we can exploit it. We'll just use autopwn. Local host. You can do this on any host, but the local host, if you run it as local host, it'll do the local check too. It's got like a little, if whatever. But if you don't, it won't execute the local check, so it won't kind of, that's common sense, but anyways. And hopefully, autopwn will work here. So I'll briefly show you the payload is it's going to add a user account, and there should be no exploit account here. Great. So you just see the user and the ASP machine count and the guest. So hopefully that will change very soon. So we're going to autopwn, and it it's just basically just runs a Perl script with the exploit, but I named it .sp because I thought that was cool, but I don't know if it is. And then payload sent, and where it's an egg hunter, it may take a few seconds for it to go, so we'll wait a couple seconds here. But it just sends the payload, and then you got a nice little screen that says, in the real thing it says the title, the vendor, and the product and everything. But in this, I changed everything. So, and it's been a couple seconds, so let's check. Hopefully, we should see. Okay. And we executed the code on the server. And we have a nice little exploit account with the password where. So, yeah, that's the demo of the 0 day I had in server. Thank you. should have like done some like dramatic music. Maybe that would have helped. I don't know. Everybody's like, hey, should we clap or should we just? I don't know. It's 0 day, but I don't have it, so I don't, okay. But yeah. So you can put whatever payload you have. I don't currently support more than one right now, which, like I said, it's just a proof of concept framework. And I really haven't done that much dev on it for probably 2 or 3 months, except getting this presentation ready. I had to change all the stuff. But yeah, I thought it was pretty cool to have my own framework to do that. So it's rock control, right? So rock control. I don't think I have a rock control on this keyboard. Let's use this. Oh, that'll work. Okay. We'll leave it pwned for now. I'll restore it later. Okay. Everybody leaves after the demo. That's cool. All right. So demo, and I just had to put a few recommendations here. Vendors. I really think you should try to break it before you ship it, because, or it'll get broken after you ship it. It's kind of, I don't know. And for the clients, I mean, I think it would be fair to say to do a security evaluation before you make a purchase, because lots of the websites have free trials and demos for the for SCADA software. You'd be surprised how many you could find out there just by, I guess you could call them and tell them you want to request or something, but I guess you probably have to be in a company to do that unless you just wanted to. But a lot of it's just free downloads. Some SCADA software is just free. I mean, it's probably not that good, but yeah, a lot of it's got free trials, like I'll show you here in a second. So I just wanted to say SCADA software can be just as vulnerable as your typical download.com application. And everybody knows when you want to own something, you'll go to download.com, download some mom and pop app and own it, which is if you're bored, or if you can own something that's worth it, but whatever. And I just want to show you like a page off the proficiency. You can get a free trial of the DVD program, like this is how you can get the free evaluations. So you can check the software out before you buy it, for the clients, or check it out and find bugs in it and do presentations or something like that. So thank you.